Okay, so one of the most common test thing is L'Hopital rule, and so Chris is not here again.
Yeah.
Yeah.
I don't know. He wasn't here first.
Senior writers had everybody. Yeah?
He did one page on
What'd you say?
nothing. Well, it was showing just myself.
I said he shot up a little bit this week. When? I mean, he did some homework.
No, he did more homework than Willie actually. No, not the same. He actually did a nice homework yesterday. All right. What's L'Hopital? Now it's two different spellings. Sometimes, according to variant, it says English spelling is gonna be L'Hospital, but in French it's gonna be L'Hopital, but he's actually L'Hopital. So what's L'Hopital rules? L'Hopital rule says certain things. He says 0/0 is indeterminate form. We already know 0/0.
Is there a pencil sharpener around? Here it's.
Okay? And infinity over infinity, that's another indeterminate form. So this is the AP exam popular. This is AP exam. This is the one that you can use L'Hopital rule for AP exam. Now, if you're following year that says like Cameron or Alex is going to take Calc 2 next year in college, you look at me like, no. You better pass it this year.
No, dude, bro. Calc 2 is very easy,
bro. So they are all the rules when you're taking Calc 2. But it's not on the AP exam. It's not even on the BC exam, but it's in the college calculus. So I'm going to mention those also. Is 0 times infinity. That's one of them. It's also known as indeterminate form. 1 to the infinity. And you think about 1 to the infinity is 1. Not entirely true. We're going to show you that. 0 to the 0 power. And infinity minus infinity. This happened in college calculus. They love this topic. And I can understand why, but it's not for BC either. But they love this topic. This is for college calculus. Okay? So what L'Hopital rule says, L'Hopital rule says this. Says if you have limits x approach to a number c, it could be infinity, of f of x over g of x is indeterminate. It's indeterminate. If it's indeterminate, then the L'Hopital rule says, hey, instead of looking at the numerator and denominator, you can look at the rate of the denominator and numerator. So you can look at the limits as x approach c of f prime of x over g prime of x. Is that okay? F prime of x over g prime of x. With that being said, you just take a derivative of numerator and denominator. But it has to be, so before you use the indeterminate form, before you use L'Hopital rule, it has to be fraction. Okay, so it need to be fraction before you use the L'Hopital rule. Need to be fractions. Need to be a fractions. Because it's f of x over g of x. So what I'm trying to say is this. What if you have limits x approach 0 of e to the 2x minus 1 over x? You'll like this rule because this is so easy. Unfortunately, what happened? What do we do when limits x approaches 0? What do you do first?
You plug in like 1.
No, you plug in what? 0. Yeah, you plug in 0. So what is e to the 0? So it's 0 over 0, right? However, I'm going to say this right now. Please pay attention. AP exam do not accept this. Don't accept this. Instead, AP exam wants you to write like this. Limit x approach to 0 of e to the 2x minus 1. You have to set the numerator. And you have to say that's equal to 0. I don't agree with it because Cauchy doesn't agree with it either. And there was a limit x approach 0 of x is also equal to 0. So then you can say, because of this, you can say via L'Hopital rule. And you're going to write like this. You're going to make sure you write this. First, numerator equal to 0, denominator equal to 0 in order to use the L'Hopital rule. I don't know why, but FRQ, you have to do that. MCQ, you don't. FRQ, you have to write it out in order to activate L'Hopital rules. Then you say, okay, well, limits x approach 0 e to the 2x minus 1 over x. We know 0 over 0. Then we can say, hey, let's do limit x approach 0 of d to the dx. E to the 2x minus 1 over d to the dx over x. Just take the derivative of the numerator and denominator. Here's the thing. If we don't know what happened equal to 0, we know 0 over 0. What L'Hopital suggested says, well, we cannot look at the function. We could look at the rate of the function. If I were to look at the rate of functions, it should give you a precise value. So what's the derivative of e to the 2x? And what's the derivative of x? And now is a plug-in. What happened if you plug in right now? You get 2. E to the 0 is 1, so you're going to get 2. That's it. That's all you have to do. Super easy.
Can we open the door for tea?
Yeah. Remember this question a long time ago? Remember that x approach 3 as x squared minus x minus 6 over x minus 3. Remember this one? How do we do this one before? You factor, right? So you can do L'Hopital rule here. I'm going to show you. If you factor this, it's going to be limit x approach 0, x approach 3. It's going to be x minus 3, x plus 2, right? And you go, and that becomes 3 plus 2 is 5, right? Now, what happens if I choose to do L'Hopital rule? L'Hopital rule, it says x approach 3. We know it's 0 over 0. So we can take a derivative, the top and bottom. What's the derivative of the top and bottom? 2x minus 1, right? Over 1, right? What happens if you plug in 3? You get the same answer, right? Except in L'Hopital rule, in terms of FRQ, you have to write like this. But most of the time, I will say, oh yeah, that's 0, 0. I'll just take it to top and bottom and plug in. Yes.
Why don't we do loading ID load?
It's not derivative of the whole thing. It's derivative of only the numerator and derivative of the denominator. Yes, that's a very good point. Cameron posted. It's not quotient rule. It's just take a derivative of the top and just take a derivative of the bottom. Is that okay? Is that okay? So this is actually a very easy rule, right? Anybody can do this. Okay, let's try another one. What happened when limits x approach the infinity of ln of x over x? Now it's reaching infinity this time. This is easier than volume, easier than anything. So remember, if it's on MCQ, you don't have to write it that way. If it's FRQ, how do you write it? You split to two different one. What is this equal to? Ln of infinity is what? Infinity. This is equal to infinity. So this is the FRQ. You're gonna write it like this, please. Okay, but MCQ you can just say, oh yeah, that's infinity over infinity. I just take it to top and bottom. So that's be 1 over x over 1, sorry. What happened when they reach infinity? That's it. Very easy. Is that okay? Now here's my question. On BC, there's a question like this. It could be on AB as well. It's also on AB exam. It show up like this. As limit x approach infinity of x to the 50 over e to the x. Over 2 to the e to the x. Actually, just e to the x is fine. Now I want you to think about this one. No, e to the x and x to the 50 power. X to the 50 power. What do you think the answer of this one is? Hmm. No, it's not. I know you know. You're supposed to know. You're in BC.
Done this question.
Mhm. What do you guys think?
I think it's 0.
Why do you think it's 0? It's right.
Okay, so the first time we do L'Hopital rule, or however it's pronounced, we get the top is 50x to the power of 49 over e to the x. E to the x doesn't change, and so we can keep doing L'Hopital rule since both still equal infinity over infinity. But eventually, that numerator is going to run out. E to the x, though, it doesn't run out. It keeps going as e to the x forever, and so it'll always equal infinity, no matter how much time we take the derivative. 50, the numerator, however, will eventually get to 0, right? So it's going to be, so it's eventually going to be 0.
Does everybody understand what he's saying? Because if you keep on doing L'Hopital rule for 50 times, because L'Hopital rule can be done twice or 3 times actually. You can keep on doing it until it works. So in this case, you can keep on doing that, which is 50 x to the 49, and actually numerator will eventually become 50 factorial. By the way, what's factorial? So 5 factorial is equal to 5 times 4 times 3 times 2 times 1 is equal to, I believe it's 120. Not sure. Somebody check my math. Yeah. 4 factorial is equal to what? 4 times 3 times 2 times 1. I think that's 24. 3 factorial is 3 times 2 times 1 is 6. 2 factorial is what? 2 times 1, which is 2. 1 factorial is what? What is 0 factorial? It's 1. The reason why is from here to here is divided by 5, right? From here to here, you divide by 4, right? From here to here, you divide by 3, right? Divided by 2, right? And this divided by 1. So 0 factorial is 1. Now, eventually, you take a derivative, it will exhaust all the exponents. But the bottom, it doesn't matter how many times you take a derivative, it's always going to go to e to the x. So at this case, it's going to be a constant over e to the x. And eventually, that's going to go to 0. So that's still answer equal to 0. Good job, Stefano. Nice thinking. Okay. Questions? Yes.
So you said you can do L'Hopital rule like many times.
Yes.
Can you show like you doing it twice? 'Cause I don't understand how you can do it twice.
You can do it once because it's still indeterminate form. Long as they're indeterminate form, you can do it over and over again. Because you can instead of study rate, you can study rate of the rate.
When you take the derivative, you just take the second derivative.
Yeah. You take a second derivative of the top and second derivative of the top, bottom. It's not quotient rule. Is that okay?
Yeah.
All right. So how much time I have? Good. I'm going to talk about this one, which is this one is not on the test. It's not on AP exam. And so limit x approaching infinity of 1 plus 1 over x to the x. This is a very infamous one. This is the infamous limit. This limit is actually done by Euler himself. And it's actually kind of cool. But what happens if you approach infinity? 1 plus 0, right? To the infinity, right? You get 1 to the infinity, which is known as indeterminate form. So that means I have to apply L'Hopital rule. But how do I apply L'Hopital rule? If I want to apply L'Hopital rule, it must be in the fractions. Is this in the fraction?
No.
No. But we can make a fraction happen. So what we're going to do is we're going to say this is a y equal to. Now, first predicament is the power. What's the power? The power is not a constant. It's an x. So what do we mention before? When the power is x, what do we do? How do you bring the x down? How do you bring the x down? Would you say? Natural log both sides. So Stefano and Emilia was both on the track. He was talking about an ln or e, but it's actually ln. So I can ln of y, right? Limits as x approaching infinity of x ln of 1 plus 1 over x. Is that okay? I can use an ln and apply both down. Now, is this a fraction? No, it's not a fraction. So how do we make a fraction? I'm going to show you one of the exponent rule is actually pretty cool. It's a to the n is equal to 1 over a to the n, negative n, right? Would you agree? A to the negative n is equal to 1 over a to the n. Well, that's true, right? So can I make this x to becomes denominator but becomes x to the negative 1? Like this. Why? Because x can change to 1 over 1 over x, right? Is that something? Is that something? Because the x can move down, it will be x to the negative 1, and x to the negative 1 is 1 over x. Right? X can equal to 1 over x to the negative 1. It's 1 over 1 over x, right? Does that make sense? What happened is what we're going to do is now we have fraction. Now I can d to the dx here and d to the dx here. Is that okay? What?
You have to derive y too, right?
No, you don't, because we only apply I'll have the rule in this situations here. But this part is L and a y, right? Because only in this part is indeterminate. Because if I reach infinity, what will happen? It's going to give you 0 over 0, right? So remember, this is a u. What's the derivative of natural log? U prime over u, right? So that means on the bottom is 1 plus 1 over x. What's on the top? What's the derivative of 1 over x? X to the negative 1, so it'll be negative 1, x to the negative 2, right? And the derivative of 1 over x, same thing, right? Do you see that happen? You take a derivative of numerator and you can take a derivative of denominator. This will cancel out, and that becomes 1 over 1 plus 1 over x, right? What happened when limit x approach infinity? Equal to what? 1. And you're gonna be like, dude, you could have told me that. I could have told you that very beginning. 1 to the infinity is equal to 1. Question mark, right? But I say it's not 1. Why it's not 1? Yes. It's equal to 1 on the right side, but it's ln y is equal to 1. So y is equal to e. So this is a definition of e. This is not on the test. But the derivative top and bottom, those on the mock exam, and that's also on my test. What?
When did we have the test?
Well, it's not today, so, and
So tomorrow since just to have one of those the cross section and the rotation and carry on.
I'll put a test next week. But you gotta study for the mock exam, so tomorrow we go over all the multiple choice.
This one kind of makes sense. And not this, but like the other parts make sense. Not this. Not this one.
Stefano. If you wanna meet me on Saturday outside the school, we can take care of that. The marketing. If you want to. If you
Okay.
want to, because I know you need an extra time, and I don't think you don't need an extra time, but you might think you need an extra time, but you don't. I don't think you do. But
It'd have to be pretty early in the morning.
that's fine.
Um,
I can meet
because,
you outside of
because
school.
I need to go like straight at 11:30 on Saturday to Miami to meet with my grandparents,
So
and then Sunday I don't think I can make that
that's right.
because of that. So
What?
that
How do I
that
make
should do.
sure I don't make no mistakes if it's gonna be next week? 'Cause I'm afraid I'm gonna forget.
Yeah.
No,
deal.
you don't look.
Okay.
The problem is you're afraid that you're gonna forget. You have to try to understand the material rather than forgetting. So if you ask Neha to take a test today or next week, it's gonna be the same result. But why is the same result? Because she tried to understand the topic. She's not trying to memorize the question.
Mhm.
So there was a video by Neil deGrasse Tyson. He says something is actually profoundly interesting. He says people. He said there's a person who wanted to hire somebody. I'm a CEO, and I want to hire an architect, right? And he says the person comes in and get an interview. And the CEO says, do you know how tall this building is? And he's like, well, no. I says maybe 150 feet. And that matter of fact, I know it's 150 feet because I study about this building. It's 150 feet. Second person coming to interview says, do you know how tall this building is? He says, I have no idea how tall this building is, but I'll find out.
Mhm.
So he go outside, he measured the length of his shadow,
Mhm.
and he measured he
You
knows
told
the
me
size.
this. I know this one. He measured it with all the shadow versus like the ratio, and then he did it for the building.
Yes. And so which person the CEO will hire?
The shadow guy,
Why?
because he knew how to do it without having to memorize it.
Because he understands it.
Mhm.
So you need to prefer to understand because you have AP exam.
Mhm.
And there's 6 AP exam.
Mhm.
Yes. And this is your problem, right? You got AP Chem, AP Cal, but try to understand material and don't try to focus on the things you don't understand. Try to focus on what's one thing you understand.
Mhm.
If you keep on focus that and keep on repetitive doing that, you'll be fine. SAT is the same way. SAT is exactly the same way. Understand rather than memorize how to do that particular problem, because that doesn't matter which time you take it. You can be taken 2 years later. It's fine. Like Unicircle, you're supposed to be able to teach your grandchildren,
Oh, I know how to do it.
right? Because you understand it. So there's a difference, right? So try to understand. It doesn't matter which day you take a test. You could be take a test next year if you understand it.
Thank you.
Be positive.
Got it.
You're too negative sometimes.
Oh.
Your boyfriend's good though. He's always positive.
Morning, Monsieur. And you're Oh my gosh, bro. What? I know it is.
Who?
Oh, so serious, I think that Valley is the relevant.
He was like,